This is a video for AQA Further Pure Mathematics. Calculus section 6.4, Surface Area of Rotation in Parametric Form. Well, we saw in a previous video that if we have a curve rotated about the x-axis, then we could consider the surface area as being the summation of lots of bands, with each band having an area 2 pi y delta s, where y was the radius of the band. And that gave us a surface area in total being an integral of 2 pi y ds. Now if we've got a function in parametric form, in other words we've got x is some function of t and y is some other function of t, we want to be able to integrate with respect to t. So then this becomes the area is equal to the integral from a to b of 2 pi y ds by dt dt. But we've got an expression again from previous videos that ds by dt is equal to the square root of dx by dt all squared plus dy by dt all squared. So that we can substitute that to give our final expression, which says that the area will be equal to the integral 2 pi y, and then instead of ds by dt we can write dx by dt all squared plus dy by dt all squared, and then taking the square root of that, or to the power of half. And this will be an integral with respect to t, so we must have limits of that from t1 up to t2. So if we've got functions for x and y, then we can substitute for y here, and then the derivatives dx by dt and dy by dt into the expression. That should then produce an integral that we can evaluate with our usual methods. Let's consider this curve then, which has been defined parametrically by x equals sine t and y equals cos t from t equal to 0 to t equal to pi by 2. So if we look at the curve, this point here will be at t equal to 0, where we've got cos 0 equal to 1 and sine 0 equal to 0, and here we have t equal to pi by 2. We're going to rotate that through 2 pi radians around the x-axis, and we want to calculate the surface area. So within our integral that we need to evaluate, we first of all need to work out dx by dt. So if x is sine t, then dx by dt is equal to cos t, and y is equal to cos t gives dy by dt equal to negative sine t. The integral requires us to have dx by dt all squared plus dy by dt all squared, and then take the square root of that. So that is equal to the square root of cos squared t plus sine squared t, which of course is equal to 1. So when we work out the area, which is the integral 2 pi y, and then our expression for the square root of dx by dt all squared plus dy by dt all squared dt, then we can substitute for y as being cos t and for the square root as being 1. So we get 2 pi multiplied by the integral of cos t, and that of course is then integrated between 0 and pi by 2. So this is equal to the integral from 0 to pi by 2 of 2 pi cosine t dt. The integral of cos t is sine t, So that's 2 pi sine t evaluated between 0 and pi by 2. Well, pi by 2 sine t is equal to 1, and at 0 sine t is 0, so this is equal to 2 pi. Now that concludes this particular video, and also concludes the series of videos on arc length and surface area.